Today we will learn about different properties of chords in a circle. So here we go. I have a theorem up here. When two chords intersect each other inside a circle, the products of their segments are equal. In other words, if you have these two chords, then that intersect, then A times B, which is what we have here, equals C times D, which is what we have over here. So let's take a look at some problems here. Alright, find the value of x. So one thing I'd like to note is, one good thing to remember is numbers on the same line go together. Numbers on same line That's a good rule here. So what I mean by same line is, take a look at this. 10 is on the same segment over here as 2, same chord as 2. So we have 10 times 2 equals, and my other chord. For this other chord, x is on the same segment as 4. So 4 times x. So solving for x, 20 equals 4x, divide both sides by 4, x equals 5. So there's an example of intersecting chords. Next theorem. In a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So what this means is if you have a line from the center going to your chord and it is perpendicular to the chord, what that does is this chord's bisected. So this part and this segment are congruent. It also bisects the arc, which tells me that this arc right here and this arc over here are congruent. So I have congruent chords and congruent arcs. So let's do an example. Over here, given that chord BC is 15 centimeters from the circle, from the center of the circle. So from the center to where chord BC is, which is right here, it's 15 centimeters away. And it has a radius of 25. Solving for two things. First, solve for BC. So first I want to find BC, which is my segment over here. We can do that using the Pythagorean theorem. 15 squared, a squared plus b squared equals c squared. In this case, we're missing b. Solving for Pythagorean theorem gets me b equals 20, which means this segment right here is 20. And what we just learned over here, outside, is if your segment is perpendicular to the chord, it bisects that chord. Because this chord is bisected, if BD is 20, that means DC is also 20. So to find BC, my entire chord, we add the two parts, 20 plus 20 equals 40. So that lets me find BC. Let's go ahead and solve for the next portion, DE. So DE is just this bottom part right here. It's hard to see. This bottom part right here. Notice that AE from A to E is also a radius. What I mean by radius is if I draw a line from the center to out here, that's a radius. Our radius is 25, which means this segment which I just drew is 25. This portion up here, also 25, which means AE down here, AE, let me write that down, is also 25. So to find DE, what we can do is take 25 minus 15 to get 10, and that is DE. Next example about congruent chords, or congruent arcs rather. Okay, so for here I just want to focus on this last part, find that arc. We have a 60-degree angle over here, which is a central angle. Let me make a note that your central angle equals your arc. Central angle equals your arc. So if my central angle ACE is 60, that means my arc down here is 60. Equal. Now we said that because my radius is perpendicular to the chord AB, it bisects my arc. So if this side AE is 60, EB over here is also 60. And now to find arc AB, we can do 60 plus 60 to get 120. My third property. In a circle, two chords are congruent if and only if they are equidistant from the center. So what this means is, from my center to the chord, if that segment is congruent to another center to the other chord, this part and this part are congruent. What that tells me is this chord is congruent with this chord. And furthermore, I'll add an addendum to this. Congruent chords have congruent arcs. So this arc is congruent to this arc. So let me make that addendum. Congruent chords have congruent arcs. So that's what these mean right here. So let's take a look at these two examples. Alright, number 6. In circle A, we have segment FG equals 3x minus 4, which is a chord for this circle. And segment HJ is 14, which is my other chord. Find the value of x. Note that since AL equals AP, this segment AL is equal to this segment AP, we can now say FG equals HJ. So there's your reason. So my equation is 3x minus 4 equals 14. Solving for x. We get x equals 6. So there's our three properties. Okay. When you have two chords that intersect, then Given this setup, A times B equals C times D, where A and B are numbers on one chord, C and D are numbers on a different chord. When you have a radius, or really any line, from the center that is perpendicular to the chord. So let me make a note of that. Line from center is perpendicular to the chord. Then what happens is it bisects your chord, so this part is congruent over here. It also bisects your angle, or your arc, this part congruent over here. And last part, if your two chords are equidistant from the center, so from center to chord and this center to chord, these are the same length, then these two chords are congruent. And also, if we have congruent chords create congruent arcs. Alright, so let's bring this all together and practice over here. So, given this question, I want to, number one, solve for x. Since PA is perpendicular to CE, write it down. Since PA is perpendicular to CE, and P is on the center, we know that CE is bisected. So my equation is 2x minus 4 equals 8. Solving for x. Oops, that should be divided by 2. Let me fix that real quick. Next up, I want to find the length of DF. So DF, I have no numbers, no expressions, no x's going on over here. But since PA equals PB, from my center to that chord, and it's perpendicular, equals to center to the other chord, it's also perpendicular, we can say CE is equal to DF. These two chords are the same. So calculating for CE, we have this side is 8, which makes this other side also 8. That comes from up here. CE is bisected, so if this side's 8, that side's 8. Which means entire CE equals 16, 8 plus 8. And because CE and DF are the same, that means DF is also 16. Last example. Number 3. Let's solve for y. Alright. So coming from number 2 tells me that CE is the same congruent to DF. So, since segment CE is congruent to segment DF, We can therefore say that arc CE the measure of arc CE equals measure of arc DF. Remember, congruent chords create congruent arcs. So my equation now is 2y plus 10 equals y plus 50. And we solve for y. Minus y minus y. Y plus 10 equals 50. Minus 10 minus 10. Y equals 40. So here you have an example of these two properties. That if your line from the center to the chord is perpendicular to that chord, so this is what we have, PA perpendicular to CE, that means the chord CE is bisected, which lets us set up this equation. So that's from this property over here. Next, because your line from the center to the chord CE is equal to that line from the chord DE, or DF, sorry. So PA equals PB, from here to here is 5, here to here is also 5. That means both chords are the same, they're congruent, they're equal. So if CE is 16, that means DE is 16. And lastly, because this chord and this chord are congruent, that's what we have over here. This CE and DF are congruent, that means arc CE is congruent to arc DF, which lets us set up our equation right here. So there you have arcs and chords.